Hi everyone, this video we will talk about how to find the domain of functions. And there are three types of functions that we need to watch out when we look for the domain. The first one is quotient functions. The quotient functions have a form of f of x equal p of x over q of x, where q of x cannot be 0 because we are not allowed to divide by 0. The second type of the function is the square root function. It has the form of f of x equal the square root of some function inside. And for this type of function, g of x, which is the function inside the square root, have to be greater than or equal to 0. Okay? And then the third type of function is the combination of the one and the two, the first and the second function, which is f of x equal p of x over the square root of another function. So in this case, since down here we see the denominator, the denominator is a square root. So this function first is have to be greater than 0, but it cannot even equal to 0. Let me say it again. The g of x, the denominator, cannot be 0 because it's in the denominator, and it has to be positive. Okay, so let's see as a few examples for these three types of function. Suppose I have f of x equal 2x over x minus 3. Okay, this is a quotient function and we are not allowed to divide by 0. So we are going to set the denominator not equal to 0. And then we just solve for x. This will give us x can be 3. All right, so we know that the domain of this function is everything, all the real numbers but 3. Then look at the number line. Starting from the left is negative infinity and on the right is positive infinity. 0 in the middle and 3 here on the right side of 0. The domain of this function is everything on the left of 3 and everything on the right side of the 3, but not number 3. Okay? So how do we convert what we just said in a interval notation? The interval notation starting from the parenthesis and the negative infinity to 3. Okay, this set of number is all the number that's between negative infinity and 3. We go from the smaller number to the bigger number from left to right. All right, and the second piece of this domain is from number 3 to positive infinity. Now we need to connect these two pieces by a union symbol. So kind of looks like a U. It means the union. Okay, so this is the domain of this function. Okay, now let's look at the second type of function, the square root function. Suppose we need to find the domain of this square root function f of x equals square root of x plus 4. The square root function say that it will divide on all the number that make the function inside the square root greater than or equal to 0. Okay, so we need to set up this inequality, and then we solve for x. So it tells us x is greater or equal to -4. Okay, now look at the number line. Okay, the domain of this function is all the number that greater or equal to -4. So that means we include the -4 and everything on the right side of this function. So the right side of -4. Okay, now let's convert what we just said in interval notation. So we use a square bracket. It means we want the number -4. And we want everything up to positive infinity. So here is the domain of this function written in interval notation. Okay, now let me talk about example 3, where the function is a combination of the first and the second example. Okay, so let's look at this example. We have something divided by something, which is a polynomial or a function divided by another function. However, our denominator is a square root function as well. So first, the square root x plus 4 cannot be 0, and the stuff inside cannot be negative. So we have to set up what we just say as x plus 4 greater than 0, but cannot be 0 because it's down in the denominator. So let's go back to the previous example. We see we have the equal sign up here, but down here we no longer have the equal sign because it's the denominator. Okay, now we just need to solve this. It gives us x greater than -4. It's strictly greater. So let's draw the number line again. Here's -4, here's positive infinity. We say that we want everything be on the right of -4, but not -4. So we have the empty dot there. And we want everything else on the right of -4. Now, how do we present this information using an interval notation? Because we don't want -4, so we use a regular bracket or a parenthesis. -4 and go up to positive infinity. And this is the domain of this function in the example 3.